So this point, okay, CC is at 1/2 sigma y. Okay, at 1/2 sigma y, and then it will be the point where we meet the Euler formula. Okay, and then this point, okay, will correlate to the CC, which is the L over R critical. Okay, and you need to find this value. Okay, so for each of the structural material, then you look into your column and check whether your LR is before or after CC. If it less than CC, so we can calculate the critical stress using the Euler formula as usual, and we can calculate the allowable stress as the sigma critical stress divided by factor of safety, and that value of the factor of safety is 1.92. Okay. And if we have the L over R is bigger than CC, which is in this term here, okay, so bigger than CC, and we need to use this formula here to calculate the value of the critical stress and also the factor of safety. So you need to put the value of L over R of your column, okay, so into this part here and your CC here. Okay, so and we also need to include the term of sigma y into our calculation. So we need to get this value here. So, and if our LR is exactly at CC, then we can just use our critical stress as 1/2 sigma y, and then CC square is equal to 2 pi square E over sigma y. Okay, so we can get this value here. Okay, so we need to check first our column. Okay, so the rule is check what is the value of the slenderness ratio, and then check the value of the CC. And after we check the value of the CC, then determine where is the location of our L over R. After that, then we can find ataupun select which formula that we want to calculate. Okay, so that is the basic for the structural steel. So structural steel is confined. So sama ada you will be given a specific steel ke, and then that specific steel will have it on sigma y. And then we can get the value as the sigma y divided by 2. Okay. Okay, so for the typical stress, okay, so we will use this part here. Okay. So this is recommended by the also by the institute, so we will use this also to do our design. So basically, later on we will do an exercise, and we need to use this part here. Okay, so firstly, so you need to find the slenderness ratio, okay, at the junction of the two equations, so which is this part here. Okay, so this part here, so value here. So this will be our CC, and our CC here is located at 0.39 sigma y. Okay, so if it's not given to you ataupun it is not lined up for you, so you need to draw it yourself. Okay, so find the value of sigma y, which is this maximum in the graph, okay, so in the plot, and get the value of the 0.39, and then plot the value at the graph. Okay, and then whatever value it is, it will be this point here, so CC here. Okay, and then we will have the critical stresses. Okay, so for critical stresses at AB, okay, in between of AB here, so the critical stresses is given as this formula here. And then if it is in between BC, so after the CC, so bigger than CC, then you can get this value here. And for the L over R, so we will use this equation here, 4.71 times square root of E over sigma Y. Okay. So if, and then we will use the Fs is equal to 1.67 for the final design, in which we will have our allowable stress is equal to critical stress divided by 1.67. Okay, and this is applicable for all type of unit lah. Okay, and then we can get the value of allowable stresses using this formula here. So this is for the steel, and then we will use this elaborated concept ataupun apa nama tu point to calculate our stresses, allowable stresses ataupun in term of designing lah. So when you have the design punya um, apa nama tu? Um, question. Okay, so you need to use this type of formula. Okay, so but this is only for steel. Okay, so let's try the example here. Okay, so let's say we have a column here. Okay, so with both support at the end, and it has it is a S100 time 11.5 row steel compression. Okay, so this is the type of the steel. So we know that this is a steel column. Okay, and then we need to find it has member of E, and then we have the sigma Y is equal to 250 MPa and E is equal to 200 GPa. Okay, so basically, so from appendix C, so we find for this type of shape, so we have the information of the value is given there. All right. So now we need to calculate the value of allowable stresses. Okay, so allowable stresses for this point here. So we have our P is given here, 60 kilonewton. So allowable stresses is just P, okay, so divided by area here. So you need to change the area into the meter square. Okay, and then get the value of our allowable stress here. So P is 60 kilonewton. Okay, and then our area is 1460. Okay, so millimeter square. So you need to time it with 10 times minus 6 to change it into meter. Okay, so that you can get your value of stresses in Pascal. Okay, so you need to calculate the allowable stress because we need to determine, okay, so the um, slenderness ratio. Sorry, the critical stresses. So what will be the value for the critical stresses? Allowable stresses. Okay, so what is the value?
Forty-one megapascal.
Okay, so 41 MPa. Alright. Okay, so now, okay, so let's look into get the information here. So let's look into this part here. Okay, so it can either try to calculate the critical stress from A, B, or B, C, because we don't know our value of L over R yet. Okay, so we don't have this critical stress here. So we can choose either this part here. Okay, so if you look into this part here, so it is much easier for you to calculate through this one here. Okay, so you can calculate the value of the critical stresses. Okay, so in which the critical stresses is just the 0.877 time the Euler stresses. Okay, so Euler stresses here is pi square E over L over R square. Okay, so this is you get your Euler formula lah. Okay, so you calculate this value first, time with 0.877 and put it into the critical stresses here. Okay, so calculate the value of Euler formula first. Okay, so that we can get the value of the assumption lah. So you can use this one here. So in this cases, so let's assume. Okay, so assume, okay, so L over R is bigger than CC. Okay, so bigger than CC. So that you can use the critical stress as 0.877 Euler formula. Okay, so Euler formula. So you have your E here. So you have your pi square and we don't have our L over R. So we keep the L over R as it is first. Okay, so we will get 0.877 time. Okay, so pi square time E is 200 gigapascal. Okay, so GPA divided by L over R square. Okay, so we will keep this term here. Okay, so then apa nama tu? So you can simplify this term here. So we can get our critical stresses. Okay. And then after you get the full value of your critical stresses here, so we use this part here. Okay, so allowable stress is equal to critical stress. Okay, so divided by 167. Okay, so for this part here. Okay, so we know that allowable stress is equal, and we already got our 41 MPa. Okay, so equal to the value of apa tadi? So this term here. So 0.877 time pi square time 200 gigapascal. So what will be this value? Okay, put this part here into a number for me. Okay, so what is the value? Okay, someone give me value. Takkan seorang pun tak kira kot. Senang je ni. 0.877 darab pi square darab 200 gigapascal. Masuk dalam calculator je.
1.73,
1.7
1.73
time
time 10 power of 12
12.
over
Okay, so L over R square. Okay, so this will be the value and you will have your allowable stresses here. Okay, so we use the second formula here. So which is critical stress. So that it will be your critical stress. You need to divide it with 1.67 to get to the allowable stress. So our allowable stress is 41 times 10 power of 6. Okay, so it's equal to 1.73 times 10 power 12 divided by 1.67 L over R square. Okay, so in the end, so you will get your value of L over R square. So you can take this value here. Okay, so once you already take this value here, and then we need to calculate. Okay, so let's finish up first. Get the value of L over R square. Okay, so from this value here. Okay, so you already get your critical stresses. Okay, so from our second formula, okay, second formula is allowable stress is equal to CR divided by 1.67. Okay, so calculate the value for L over R square. Okay, so what is the value?
Madam,
Hmm.
uh, is that the value of 11.67 beside L over R?
L over R berapa? L over R square. Square berapa?
Tak, yang nilai tepi L over R tu 11.67 ke?
1.67. Yes, 1.67 time L
Ah,
over R
1 je.
square. Yeah, because this
Okay,
is
okay.
critical. So this is critical stress that you calculated just now. So we just divided it by 1.67. Right, so what will be the value of L over R square?
25.27 kilo.
Berapa?
25.26 27 kilo.
So 2, 7.
7. 7.
Okay, so then you can get your finally so your value of L over R. Okay, so because then you can do the confirmation. Okay, so just divide this into two apa square root for this one. So get the value of the L over R. Okay, square root berapa?
158.95.
1, 5.
158.95.
Okay, so this will become the value of our LR. So this is not confirmed yet, so because this is based on our assumption here. Okay, so we assume our L over R is equal to is bigger than apa nama tu CC. Then we need to calculate. Okay, so the value of the CC. Okay, so based on this equation, mana tadi? So equation here, okay? So this is our L over R, so which is our CC lah. So this is our CC. So calculate this value here. So and check whether our assumption is correct or not. So use the value here. So 4.71 square root of E divided by sigma Y. And this is already given to you in which E is the 200 gigapascal and our sigma Y is 250 MPa. Let me check. Use the different one here. So our L over R or our apa CC is equal to 4.71 times square root of E divided by sigma Y. Okay, so this is the third equation that we need to use. Okay, and then we need to check it with this part here. Is it bigger or smaller than our CC? So let's check the value of our CC. So what will be the value? Okay, so what will be the value of our CC?
133.22.
So 133.22. So does our assumption correct or not? Betul ke salah?
Betul.
Right. So our assumption is correct because our LR is indeed bigger than our CC. Okay, so we can continue. Okay, so if apa nama, we can use this value here. Okay, so of our LR. So using this part here. Okay, and then so the question is so to find the value of L. Okay, so L in which apa nama tu is the longest unsupported. So if we in part here. Okay, so we can continue with this one here. So we will get the value of our L over R is equal to this part here. So we can use this. Okay, so this value. Okay, so based on this value, so we have two radius. Okay, so choose the one that is smallest lah because we want to find the longest value. Okay, so L over R. So you can put into one by one. So L over R is equal to 158.95. So this will be our value. So to get the value of L, so we just change the R into the smallest one. So which is 14.6 millimeter. Okay, so then you can get your value of L. Okay, so the largest value of L so will be 1. So largest L. So we will get L is equal to 158.95. Okay, so time 14.6 meter. Okay, so this will become uh, our apa nama tu? Uh, Value. Okay, so we will get this one here. Alright, so basically that is how you will be designing. Okay, so a column, so in which you have to go back and forth lah between this apa nama tu, this value of calculation. So you will be indeed apa need to make assumption. Okay, so whether your CC, okay, so, sorry, your L over R is bigger or smaller than the critical apa nama tu L over R, which is the CC. So you need to find that. So let's say if, okay, so if our L over R that we calculated is here, okay, so tadi tu, the first one is smaller, okay, so smaller than CC, so then you need to change, okay. So you cannot use the value of this part here. So you need to change to BC here. Okay, so the AB here. So you need to change to this one here. Okay, so if our calculation is wrong just now, so you need to start all over again. So starting from this critical stresses. Okay, so critical stresses here. So this critical stresses is no longer from this part here. So you need to calculate it from this AB portion. So if apa nama tu, our assumption is wrong just now. Okay, so if not, so you can continue lah. So to get the value of either L ke, sigma, allowable ke. So whatever the value that is asked by the question. Alright, so that is for still. So let's take 5 minutes break and then we will continue with the calculation for the design. So let's continue. Okay, so for the previous example, so we use the for steel. So now we also have the value for the aluminium. And for aluminium, so we have two parts. So which one, which is, the first one is for the 6061. So this is the type of steel, eh? So we will have two type of steel. So one is 06001 and the other one is 2014. So you need to make sure. So if you look into the previous final exam, so it's specific. Okay, so it's specified. So which aluminium that you need to use so that you can use which apa nama tu? Um, formula. So it will be different lah. Okay. So for the 6061, so the value of CC is already specified. Okay. So for aluminium lah. So for 6061, so the value of CC is 66. And for 2014, it will be 55. So maksudnya this part here. Okay. So your CC here is either 66 or 55. Okay. So depending on the material. Okay, and then if you already know the value of your LR, so you need to determine lah, so whether your LR is in the AB portion or in the BC portion. Okay, so with these two part. If not, so you need to calculate it based on the apa nama tu? You need to manipulate the equation so that you can get the value of your L over R. All right. So if our L over R, okay, so let's look into the 6061 first. So if your L over R is in this portion, which is 6 AB lah, kita panggil ni AB. So in AB portion, so we need to use the allowable stress as this part here. So you just put in the value of your L over R here, and then you can get the allowable stress as 139 minus the 0.868 times the L over R. And if it's bigger or equal to 66, so we can just use this formula here. And the same thing with the 2014. Okay, so you will have the equation here. So basically, so this is 213 actually. So 213, and then we will have minus 1.577. So 213 minus 1.577. Okay, so MPa, or we will have the 382. So this 382. Okay, so time 10 power minus 3, power of 3. MPa divided by L over R. So you need to determine the value of your CC first. Then we can get the apa nama tu? Our allowable stresses. Okay, so we will use this equation here. Okay, so let's look into the example. So we will have this example here. So let's say we have a centric column. So for all the formula that we just used just now, so that is all for the centric loading. Okay, so when your loading is exactly at the center of the column. Okay, and then let's look at this example here. So using the aluminum alloy, so determine the smallest diameter rod that can be used to support the centric loading of 60 kilonewton if L is equal to 750, and then if L is equal to 300. Okay, so for this one here, so we need to, first of all, so we need to get the relationship, okay, so between your diameter and also your L over R. Okay, so because the diameter is not specified, so we can get the value of the diameter. Okay, because our L is given here, so we need to find the L over R. So in order to get that, so we need to find the relationship between the R and also radius, okay, ataupun diameter. Okay. So if we have a circular ataupun if we have a cylinder over here, so we can relate the value of radius of gyration with the value of I. Okay, so I is equal to for the cylinder, so this will be pi r power of 4 divided by 4. And we also have the value of our area, which is equal to pi r square. So we can get the value of r from this part here. Okay, so we can get our r is equal to square root of I divided by a. Okay, so we can get the radius of gyration. So this is the radius of gyration. So we can get the, put in the value of here. So we can get pi r4 over 4 divided by r square root. So you will end up with the value of the radius of gyration is equal to, sorry, nak tukar ni. Let's change this to C to make it. Okay, so C is basically the radius here. Okay, and R is the radius of gyration. Okay, so which is used in the L over R over here. Okay, so and the value of R here, so will become C over 2. Okay, so that is the relationship between the radius of gyration toward the radius of our cylinder here. Okay, so if we have our 2014, okay, T6 here, and then we have our L over R over here. So let's look into the equation. So the equation is this part here. Okay, so we will use this part here in which we will have either L over R is smaller ataupun bigger than 55. Okay, so you can choose either one and then check whether your loading is correct or not. Okay, so let's try with the value of the bigger than 55 because this is more or less elaborated. So we can get the value of 382 times 10 power of 3 MPa divided by L over R square. Okay, so R is given there, and then we can calculate the value of allowable stresses. Okay, so for that one here, so allowable stresses, so we can get the value. So let's assume L over R is bigger than 55. Okay, so we can use our L over R is equal to 3.382 MPa divided by L over R square. So we can use this one here. Okay, so this equation here. And we can get the value of our allowable stresses in which our sigma allowable is equal to P divided by A. So P is given here, so 60 kilonewton. So divided by the area. So area is pi C square. Okay, so we can get this value here. And this value here is equal to this part here. Okay, so L over R square. Okay, so you need to change this part here. Okay, so we will get 382. So R is equal to C over 2 just now. So we can put the value of our C, L, which is 750 millimeter. So divided by C over 2 square. And this is equal to 60 kilonewton times pi C square. Okay, so that will be our calculation. And then we need to check, okay, so what is the value of our C? So you can calculate the value of our C and then from this equation here. Okay, so let's try to calculate the value of C.
Eighteen point three one.
So berapa?
18.31.
So after you get the value of your C, so this is in meter or
Millimeter.
so millimeter, right? So you can get your value of your C is over here. Okay, so 18.31. Then you need to check again. So what is the value of our L over R? So what is the value of L over R? Because this is based on the assumption. So our L is given there, so 750. And our R is here. Okay, so 18.31 divided by 2. So you should get 9.6 something. Okay, and what is the value of R?
81.9.
So, berapa?
81.9.
Okay, so you will get this value. Alright, so does our assumption correct or not?
Yes.
Okay, so because 81.9 is bigger than 55. So if not, then we can use directly. So the value of the C here. Okay, so if our assumption is correct, so this is indeed bigger than 55. So this is correct. So you can use the value of your C as diameter. Okay, so diameter as 18.31 times 2. Okay, so that is how you do the value for this calculation here. Okay, so for all of these equation here, so this is and then you can try with the 300 millimeter. So you can either, if you still didn't get the answer, if you do the same assumption, okay, so you of this one here. So if you try with the 300 millimeter, if it's not correct, then you need to change it into this to the first one. Okay, so 213 time minus 1.577. Okay, so always check your assumption. Is it correct or not based on the CC? Okay, so of the value. Okay, so basically, so we will have these two part here. So for the structural steel, so we will always refer to this part here. So this is already simplified for you. Okay, so we can always refer to this one here. And then for the aluminium, so we will have these two part here. Okay, so for the 6061 and for 2014. Alright, so that is exactly for the eccentric loading. Okay, sorry, centric loading, in which, okay, so your loading is specifically specified to be at the center of the column. So you need to check your column, so whether it has the E or not. So if E is 0, then we can use the equation. If not, we need to change to the second part, so which is for the eccentric loading. Okay, so let's move to the eccentric loading. To design the column based on the eccentric loading. So if, okay, so we still use the same calculation from the eccentric loading, but now we need to change it into two parts. Okay, so we will have the value of the E. Okay, so value of E here is situated at millimeter from the center of the beam. Okay, sorry, center column. Okay, and it will induce a moment couple as shown here. So we will have our P as at the center of the column with couple with the moment, which is the value of the PE. Okay, so For the eccentric loading, so we can get the value of the stresses as the combination of both. So one is from the centric loading and one is from the bending. So which is the contributed by the moment over here. Okay, so we will have our maximum stresses as P over A. So this is from the centric loading minus plus with the stresses from the bending. So which is MC over I. Okay, so that will be the maximum stresses. So in the eccentric loading, so your maximum stresses should not exceed. Okay, so should not exceed. So must be less or equal to the allowable stress. Okay, so that this is the main principle. Okay, then we will have two type of method. Okay, so one is the allowable stress method in which we will have our P over A plus MC over I is less or equal to allowable stresses. So this is first method and usually so this is specified to you sama ada nak guna allowable stress method or use the interaction method. So the second one is the interaction method in which okay so if you have the allowable stress for both value. Okay, so for the first one, so usually so we have one general allowable stress, okay, and it basically apa nama tu referring to the apa nama tu forces, okay, so general one, so we will have only one. And it will be referring to the centric stresses, okay. And if we have both stresses is introduced, okay, so then we can use the interaction method. Okay, so which is specified here. Okay, so we will have our P over A divided by the allowable stress for the centric loading only. Okay, so plus MC over I divided by allowable stress from bending only. And this value should be less or equal to 1. Okay, so if the question specified directly, so use the allowable stress, then you need to use the allowable stress. If not, then we can use either one. But before we can get into the allowable stresses, so we need to go through all the stress apa nama tu, all the uh, works that we have done previously in the centric loading to get to the either R or R. So usually, so we look into that part there. So it's a little bit longer work because we need to add on this part here. So P over A plus MC over I or P over A divided by allowable stress centric plus MC over I divided by allowable by bending. Okay, so we need to check whether we can use the specific loading or not. Okay, still need to use this part here to calculate the value for the stresses. Okay, so let's this equation here. So this is one, this question here. So this is the allowable stresses. Okay. So the question is asking you, so use the allowable stress method, determine the largest load P that can be safely carried by the W3110 column. And the value for the W3110 is given there. So you have your A, Rx, Ry, Sx, all is given to you. Okay, so S is just the I over C. Okay, so you can get it from there. Okay, so given to you. And then we have the length of effective length. So LE is already calculated. So this is 4.5. Okay, so E is given there 200 gigapascal, and then we will have our sigma Y equal to 250 MPa. Okay, so we need to use the allowable stress method. Okay, so before we go to the check the one. Okay, so using the get to the value of the L over R because the allowable stress method is basically just going to the P over A. So over here. So over here. So our allowable stress method is P over A is equal to MC over I. Okay, so divide and this value should be less or equal to allowable stress. Okay, so given here, so our LE is equal to 4.5 M. Okay, and then we need to get the value of L over R. Okay, so in these cases, so we have two type of R. So Rx is 132 and Ry is 49.8. Okay, so to make it safer, okay, so we use the smaller R. Okay, so we will get so 4.5 meter. So divided by 49.8 times 10 power of minus 3 meter. Okay, so this will be our L over R. Okay, and so because this is the steel, okay, so this is the steel, so we need to calculate this value here first. Okay, and then we need to check for this part here, so which one. So that will be in our L over R here. Okay. So for this one here, so what will be the value? So 4.5 divided by 49 times 10 to the power minus 3. So let's get our L over Ry. Okay, so what will be this value here?
90.4.
So it will be 90.4. Okay, so once you get that, so let's look into this part here. Okay, so we need to check our critical stress. Okay, so we need to check our critical stress, but we need to choose first. Okay, so what is our CC? Okay, and in these cases, so let's calculate our CC. So which is L over R is equal to 4.71 times E divided by sigma Y. Okay, so E divided by sigma Y. Okay, so what is the value here? Okay, so our E is given. So which is berapa tadi? 200 gigapascal. Okay, and our sigma Y is 250 MPa. Okay, so what will be the value?
One eighty point two two.
So 133.2. So your apa tadi? Column tadi is in AB or BC? So where is your column located? In AB or BC?
AB.
Alright, so in AB. So now you need to calculate your critical stresses from AB. So we use this equation here. Okay, so first you need to calculate your Euler stresses. Okay, so Euler stresses is apa tadi? Is pi square E divided by L over R that you already get just now. So berapa ni? So L over R tadi berapa? 90.4. Okay, so use the 90.4. Okay, so E is given there 200 gigapascal. Okay, so calculate your Euler formula first. So what is the value of sigma E? Okay, so what is the value of sigma E?
Two four two megapascal.
242 MPa. Alright, so now, okay, so now you can calculate your critical stresses. Okay, so you have 0.658. So sigma Y tadi is 250 MPa and your sigma E is 242 MPa. Okay, so we can calculate our critical stress as 0.658, okay, time the power of 242, 250 divided by 242. Okay, 250 MPa, so divide 242 MPa. Time with the yield strength tadi, 250. So time with 250 MPa. Okay, so then we can get our critical stresses. So calculate the value of the critical stresses.
162 MPa.
Apa?
162.
162. Okay, so you will have your critical stresses as 162. Okay, so then we can go back to here, to this equation here, to get the value of allowable. So your allowable stresses now is 1 divided by 167. Okay, so what will be the allowable stress value? So you will get 97. Okay, so as your allowable stresses. Okay, so at 97 MPa. Okay, so now we can go. So we already got all our parameter. So then we can go to the equation for this part here. Sorry, selection. So this part here. So we will use this equation here. So P over A plus MC over I, it should be less or equal to allowable stresses. Okay, so because we want to find the value of P. So in these cases, so our allowable stress, okay, so it's given to you. So 97 is equal to 97 MPa. So we will have our P divided by area. So A is given here. Okay, so plus MC. So M is not get there, but we know that MC over I is equal to M over S. Okay, because S is just I over C. Okay, so we can use this value here and M. Okay, so M is just PE. So PE over S, in which we have our E is given here is 200 mm. So we can just directly use the P times 200 mm. Okay, divided by S. Okay, so PE over S. So the value of S here. Okay, and this should be or equal to 97 MPa that you calculated just now. Okay, so we will end up with the value of our P, which is given here. So we can continue to calculate. So area is given there, S also is already given to you there. So you can put the value of the apa nama tu? Largest allowable load of P that you can get. So basically, so for the eccentric loading, so you still need to calculate based on the centric loading first to determine the critical and so the critical and apa nama tu allowable stresses. Okay, so then after that you can continue with the value of your P. Okay, so you should get the value of your P in Newton. Okay, so to calculate this value here. Alright, so we can also still use the same apa nama tu example. Okay, so but instead because you already solve for all the information there. So if we to use the interaction method or if the question directly specified. Okay, so use the interaction method. Then you need to use this equation here. So we will have usually for interaction method. So the bending allowable stresses for bending is given to you. Okay, so tadi you already got the value of the allowable stress centric as 97. Okay, and then now if it is given to you, the bending allowable stresses is 150 MPa. So all you need to do is just to plug in the value here. So use the same method just now. So except now the value will be less or equal to 1. So you can put back into the equation just now. So A is given to you and this you should change to M over S. Okay, ataupun PE over S. So you will have the P over A divided by 97. Okay, so plus PE over S. Okay, so divided by 150. Okay, so this is less or equal to 1. So you will get the value of your P. Okay, so that is the only difference. Okay, so any question regarding the design of the column? So your final so will be on design, so design of column. Okay, so you should be able to determine. So first, okay, so the LE. So always check for the LE first. So which LE? So sama ada you kena guna 0.5 L ke, or 2L ke, 0.7 L ke. So first of all, always check for the LE, effective length. So based on the drawing, okay, so drawing tu macam mana? So check your LE first. Then you can continue with the calculating the value of your design. Okay, so in final, okay, so if you check, okay, so the previous final paper, okay, so previous final paper, so you should be able to understand the type of question lah. So lebih kurang je. Okay, so I hope all of you will apa nama tu? Will look okay so into the final paper from previous semester so you can get it from the library. Okay, all right, so so that's it lah. Okay, so this is chapter 10. Okay, so we already done with chapter 10. So basically we will focus heavily on the design part, but since we already finished, okay, so with the question, so I think most of you will need to reorganize first your thought so that you can try to follow the method that is given here. Okay, so we are done with the chapter 10. So, yep, so we will have another half an hour. Okay, so let's give me 20 minutes, 10 minutes. So I will go through the revision or briefing of the final so that we don't have to, because Rabu kita cuti, so then we can skip the class on next Friday. Bagi saya 10 minit and then I will do briefing for the final. Okay. So alright. So since we finish up our chapter 10, mm, okay, so let's go to overview of your final later on. So your final is on apa bulan? 15 eh? Yeah. So DBP. So 17, okay, 17 bulan. So you have more than 4 weeks almost to catch up. Okay, so we will have our final at 17, 9 to 12. So, jangan bagi alasan tertidur lah apalah. So memang tak ada dapat lah. So if you don't attend, then you can not be able to be at the 10. Okay, so you will have your final here. Okay, so basically, so the format is the same. So from your previous so we will have 3 questions. Okay, so question 1 is from chapter 8 and this is around 34 marks. Okay, so chapter 8 ni is a combined loading. Okay, so combined loading. So basically, so you will be, okay, so given a structure. So kata ada structure tu and then this structure is apa nama tu, is subjected to various type of loading. So PP, okay, and then you will have okay, something like this and then apa different part here. So you need to use the method that I have shown you before. Okay, so for question 1, because this is a combined loading, so you need to start with the identify the loading. So so you need to identify the loading. So ada normal forces. Okay, so do we have normal forces? Do we have torque? Okay, so do we have V? Okay, so do we have moment? Okay, so you need to list out all of this ataupun one by one lah. So check from your loading. Okay, apa nama tu over here. So and then check whether you will have our apa betul loading or not. Okay, so usually so the question is about the location here. Okay, so hash and k tu. Okay, so hash and k. So I'm sure you're familiar with this if you remember from your assignment ke ataupun or from your apa nama tu lecture. Okay, so we identify the value of hash over k. So first you need to identify the load. So just list out. So kalau tak sure pun just list out. So ada P ke tak, ada T or V. So and put it over there. Okay, and usually so this is in you have the exist lah. Okay, so you will have the loading. Okay, so after you have the loading, so calculate the geometry. Okay, so ni dah kalau tak ada idea sangat, so calculate this all value. Area, I, J, kalau ada J lah. Okay, so because this is all related to the equation there. So because we are dealing, so for combined loading, so we are dealing with this stresses. So you ada 4 type of stresses. So we have P over A. Okay, so this MC over I, and then we have tau, which is VQ over I. T and tau is equal to TC over J. Okay, so you need to calculate all these parameter. So satu-satu. So the loading and also the geometry. So in the geometry, so basically, so you need to have these 3. So A, I, J. Kalau ada J lah. Okay, so if we don't have J, so then you need to at least calculate the value of area and I. Okay, so this part alone is almost half from your tu value. Okay, so satu lagi Q. Okay, so Q. Okay, so half of the marks. Okay, so once you get this, then you can proceed with the equation of the combined loading. Okay, so combined loading. So tengoklah question nak apa. So sama ada the question 1 to you to calculate K ataupun H. Okay, so then you need to check back. So at which stresses, okay, so sama ada dalam 4 stresses ni, which one this is available at this location. Okay, so you need to always remember that hash and k is depending on the, especially this one here. So M and T. Okay, so sorry, D is 2 here. Okay, so T is usually available and stress is always available. But this 2 is depending on the location. So whether your hash or K is at the neutral axis or not. Okay, so kalau bending M is always maximum at the edge. Okay, so you need to always remember this part here. Ni. Okay, so D maximum at edge. So kalau tau pula, so this is maximum at center. Sorry, maximum at neutral axis, 0 at the edge. So that is the difference. And you need to identify lah. So which is your neutral axis. Okay, so you need to always remember this. Okay, so ada ke tak ada? So you need to specify. Okay, dekat K, we don't have stress due to the moment. Only B. Okay, so that is the is then you can identify this once you get and you need to proceed with the principal stresses and you can use any method lah. Sama ada nak guna more circle ke ataupun the equation. But if you want to use make sure that you memorize because the question is no longer given. So you need to memorize. So that's minimum. It is not okay. So for that part, okay. So that is for the question 1. Okay, so for question 2, okay. So question 2 is from chapter 9. So question 2 is chapter 9. So which is the deflection. Okay, so deflection of the beam. Okay, so you will be either given a simply supported or cantilever. Okay, so cantilever. So this is the only things that you are tested on lah. So sama ada there will be some loading. So not a simple loading. So maybe you will have multiple loading ke ataupun this part here. So something like this. Ataupun you will have the contoh macam ni. Okay. So multiple loading. Okay. So not only one loading. Okay. So you need to do the exercise for the multiple loading, not concentrated loading. Okay. So for deflection, so we will always started with calculating the reaction. So because you need to calculate the moment, so RA, RB, so need to always check this part here. And also you need to identify your moment lah. So moment because in this case, so beam, so your M is much more important. Okay, because all the equation is based on the moment there. Okay, so once you get this part here, so I think this semester it is not specifically specified. So which method that you need to use. Okay, so you can use any the 4 method that we have learned. Okay, so to calculate the value of deflection. Okay, the value of the deflection. So deflection should be this way, and then you will have sigma y max ke macam tu lah. So the question will ask you what is the value of sigma ataupun we will have the theta A ataupun theta B. Okay, macam tu. Before that, so the question is always asking you, so calculate the value of the reaction. Okay, so reaction or moment. Okay, so that will be the first question. Because this value ataupun get the of the free body diagram. Okay, so without this value, so we cannot the calculating. And then the second one, then you can use the method to calculate the action. Or I don't add to this one unless yeah. For multiple loading. So superposition graph is given. Okay, so don't worry. So you will have the table for the superposition or you can use the moment area theorem. Kalau saya One. Okay, or this one part here. So antara dua ni lah. Okay, so which one that is comfortable to you? Okay, so if you want to master it, so try to do a few question and do the multiple loading. Okay, so using these two apa nama tu? Uh, Method here. Okay, so I don't advise to use the double integration unless you are very fluent lah. Okay, so in calculating the moment, especially for the multiple loading. Oh, we have another one. So which is the apa nama tu yang but the student never use it. So I don't think you will use it. Okay. So that is for the deflection chapter 9. And this will be 33 marks. Okay. So from the total of your final. Okay, so at least if you finish half of it, so you can get 15 ke 10 ke, so that will be okay for your marks. So total marks for the final, so will be 40%, 60%, 40, and then it will be used, determined heavily on your final grade. Alright, so the last one is question 3, is on chapter 10. So we only have 3 questions. So question 3 is 33%. So this is on chapter 10 that we just finished just now. And for this one, so we will be on eccentric loading. Okay, so eccentric loading design beam. Column. So basically, so the last question. So the one that you do it, just last question. So you need to determine so the value of your uh, critical stresses. Okay, so you will be given a loading of eccentric loading. So you need to do the designing of the column started from selection of your CC. So maksudnya you are given a material and then you need to calculate the value of your CC. Okay, so your CC is given here and then you need to check whether you will have the AB or not. Okay, so you need to get the value here. And then you need to use for eccentric loading, so you need to be able to use the equation that we have just now. So sama ada interaction or it will be specified, I think. So specified, so either allowable stress or interaction method. Okay, so you will be given here. But you need to do the full length of calculating this from started here, so critical stresses, until you reach to this value here to get the value of the stresses. Okay, so basically, so we are doing something like this question here. Okay, so these two questions. So you need to be able to do the eccentric loading design question. So as I said previously, so you need to always specify your LE. So it's equal to berapa. Okay, so after you specify this, so you need to at least show the equation of Euler ni. So pi square E over 2 E I LR square. So at least show the Euler calculation. Kalau dah tak tahu sangat nak tulis apa, so at least you show us these 2-3 things and then how to calculate the critical stresses. Okay, so these two part here. And for the design, okay, so this graph is not given to you. Okay, fine. So the graph is not given to you. So you need to so you need to apa ni? Okay, so this part here. So you need to know the value of the CC. Okay, so for aluminium and steel, this part one here. So at least these two graph. Okay, so it will be between steel and aluminium sahaja. Okay, so these two aluminium. Okay, so you need to know the value of this one. So make sure that you remember that the 46061, so it's 66. For the 2015, so the L over R is equal to your CC is equal to 55. Okay, so and then you this apa nama tu equation here. Okay, so because you need to solve for something like this part here. Okay, so if you want to solve for this one for centric loading, so you need to solve for the centric loading first before you can solve for the eccentric loading. Okay, so you should expect, okay, so for each question, so you have ada four or five question, smaller question lah. Okay, so it break down into that part. Okay, but actually, so it is just one big full problem. Okay, so you have three problem, and then you have 3 hours. So you should expect, so for each question, so you need 1 hour to solve. So the final question will be a very long problem. Okay, so those who did not apa yang just salin je assignment, tak pernah nak solve for your own. So please try. So at least try to solve for the question that is in the previous semester punya final. So you guys should apa make some study group and then share. So do the final question together and check with each other. So what is missing? Okay, alright. Okay, so that is it for your final. So I hope that you guys can do well. Okay, so even though so that you can cover with your midterm. Okay, so your midterm that is very apa ni. Okay, so for the module I will give link later and I will give the final assignment. Okay, so for the chapter 10. Okay, and then saya kena check balik lah mana yang dah buat quiz ke belum. Okay, so that will be it lah. So I think this is it. So we are done. Okay, so wait some 2. Okay, so I hope I don't see you again. So next semester, please apa nama tu? Do well lah in your final later on. Okay, so I will be available. So if you want to ask any question, so janganlah message saya pukul 11 malam, pukul 6 petang. So I work from 9 to 5 only. Okay, so at that time, then you can ask me questions. So I will be led to answer, but I will answer eventually. But if you sending me message at midnight, so memang saya tak jawab lah. Okay, so you can ask or if you need some help with the question, so you can set appointment with me. So we can do either online ataupun in my room. Okay? Any question regarding your final ataupun regarding the chapter 10? So tak ada. Okay, so if not, so we will stop here. Apa dia?
Tak ada.
Tak ada? Okay, so kalau tak ada, so we will be stopping here. Okay, so have a nice long weekend. And then this will be our last class So we don't have class on